Next up, we're going to be hearing from John McBride. John is the VP of Infrastructure and AI Engineering at the Linux Foundation, where he heads up AI and infrastructure development for the LFX platform. He has years of experience building complex software systems, scaling huge AI infrastructure systems, and rallying organizations to adopt cutting-edge technologies. Previously, he worked at open source, AWS, VMware, and Pivotal. That's a stacked CV, and I'm looking forward to hearing from all the things that John learned over those years. But today's be talking to us about demystifying the AI economies of scale. And maybe some of us might get some ideas about whether or not it makes sense to run our own AI infrastructure. John, over to you.
Hey, thanks, Sam. Appreciate it. Yeah, my name is John McBride. Thanks for coming to this talk. I think this is honestly a great sort of launching off point from Colleen's talk just on, running some hybrid things in the cloud and when some of these things can make sense. This talk is part, I guess, wax poetic and sort of theoretical, but then also part, example and some things that I've built in the past, going into some of the actual technical details on a hybrid solution that we built sometime last year. So let's get into it. Maybe the disclosure here is that with all these things, your mileage may vary. There's wildly different solutions out there, and it's very, very early. This is probably something you're going to hear from just so many presenters today. The space is just so new, and things seem to be moving so fast that even in a week or two, some of the new models, new platforms, new things could be coming out that would just totally invalidate a bunch of this stuff. And this is something I like to say a lot to people adopting AI or looking at some of these solutions or products. It's sort of a race to the bottom right now, where maybe in theory, somebody will build artificial general intelligence or super intelligence and be like the market winner. But it's just a constant race to the bottom to get that market fit. So it's not surprising that it's so early and can be so confusing, just all these different things happening. So those are some of the caveats to this talk. A lot of it is wax poetic and sort of theoretical, but let's dive in. So I want to introduce us to Mr. Bobby Startup here. And Mr. Bobby Startup just raised, $100 million for his seed round or something crazy to go build some AI product. So Mr. Bobby Startup has a question that he kind of has to ask himself as he's going to go and build this platform, some AI product, some AI solution. Maybe he already has a bunch of data. Maybe he's going to go scrape it and gather it somehow off the internet or whatever. But he needs to make a decision around how to run his AI infrastructure. And the way I sort of have seen it is that there's kind of four solutions. The top being these API services like OpenAI's API, all the way down to running your own on-premise data center with your own GPUs that you purchase and sort of going all in on that. API services, this is really the pay per token approach. You just get a simple API key and you can just start using it almost immediately. Many of us have probably gone through some Jupyter notebook or some online tutorial that plugs in OpenAI's APIs, and you're just off to the races doing AI things for your products. There are some obvious privacy and governance concerns here, and you have few levers of customization with certain things that you're just not going to get from these turnkey, or I guess I should say these API services. The next solution I see is these turnkey cloud AI infrastructure solutions like Bedrock or Gemini Studio that exist sort of on the cloud, but are a platform basically built for you. They're usually low maintenance. You have some more customization options. Sometimes they're even more tailor built for a solution that you need. Maybe you're doing some sort of deduping thing. And I know there's a Bedrock service for that specifically. And then there's also added benefits of some more governance where you maybe can deploy these sort of platforms on the cloud behind your own VPCs, where you own a little more of that data, you own a little more of the platform. So going even deeper, going further down, and some of the complexity, you're noticing is getting higher and higher, more complexity. I call this the build it yourself cloud platform. This is really where you would maybe go and use something like Kubernetes, or even just bubblegum and duct tape with a bunch of EC2 instances and GPUs that you lease off of the cloud, where you then go build your own GPU platform. And this is sort of getting more into that hybrid approach. You can bring your own technology and your own management. So maybe you have existing expertise, some existing cloud expertise, and you just want to lease GPU instances off the cloud, and you can possibly take advantage of some of those more fixed costs, quote unquote fixed costs, but we'll get into that. Key here is that you generally get better data privacy controls depending on the stack and what you BYO for your technology. Then all the way down, probably the highest complexity, but the most extreme governance is the upfront cost of building your own data center, maybe on-prem, maybe you're leasing racks out of a place that OpenAI has a bunch, but essentially you're going all the way in. Risky long-term benefits, I'll say, because you're buying a bunch of GPUs potentially, or leasing them, renting them from a data center, and then you have that extreme ownership, and you have to go all in with managing that. So that's kind of how I have seen the field, at least from my eyes, play out with these sort of different approaches, and mix and match a bunch of these to your own benefit as well. Okay, so let me go back to my slides. Whoops. There we go. Okay, so this is the first graph that I want us to be familiar with, and this is sort of where we get into like the wax poetics of what I call like these economic laws as you scale. On the left side, we have cost going up, and on the other axis is usage. And as usage, in theory, goes to infinity, your costs just continue to aggregate over time. And this is the third-party APIs. These are the APIs that are token-based, and as you use more tokens, linearly that cost is going to scale with you. So token-based with linear scale usage. And it gets extremely expensive when you hit that hyperscale because you're linearly scaling your usage with your costs. Now, the next graph that I think is good to be familiar with is kind of the opposite, where you sort of have a flat fixed cost with some variables in there, you'll notice from my squiggly lines. And this is the opposite end of that, where you have like all GPUs, all in, you're building your data center, you're managing it. In theory, you can just continue to use those GPUs and do inference on those GPUs without having to pay that third-party per token cost. So the reason I made these lines a little more squiggly is because fixed cost is not always truly fixed, but this is a huge upfront cost and investment. You're going and buying GPUs, a bunch of H100s from NVIDIA. That's just going to be a massive upfront cost. But in theory, down the road, as your usage scales to infinity, you in theory can just continue to do inference on those GPUs with some management costs and potentially some costs for actually using those. Relatively fixed costs that do not scale with usage. And we go on. So this is sort of the hybrid that I imagine and that I've seen sort of work out where maybe you hit what I call an inflection point. And this is where you have that fixed cost that starts to look really, really good. So all the way down to the bottom left is really where maybe you're using token-based services. You're just getting inference from OpenAI or Anthropic's APIs, and it's extremely low cost for your extremely low usage. But as maybe Mr. Bobby Tables, Mr. Bobby Startup gets his product more adopted and that continues to scale and they're using more and more tokens, that cost scales linearly. And eventually you reach this inflection point where maybe Mr. Bobby Startup says, okay, we need to kind of fork off on the green line and actually adopt some more fixed costs. So these fixed costs of reserving GPUs or building your own platform starts to look very appealing. And here's, again, one of these caveats in this wax poetic talk is that these fixed costs are never really truly fixed. GPUs fail quite frequently, actually. They can legitimately just fall off the rack depending on how like the PCI slot looks. And those cloud management costs, even though in theory they can be fixed month to month, may increase, decrease depending on your capacity, how you increase or decrease capacity, as well as how you handle management and engineering for those platforms. So that's the caveat in this is, the squiggly line, fixed costs are never truly fixed. Now, this whole like red area right here, taking us back to a bit of calculus, in theory, this red area should expand to infinity as our usage expands to infinity. And that means that the potential cost savings should grow to infinity as your usage grows to infinity if you hit that inflection point. So the idea being that this is essentially unit economics, that the unit scaling for the fixed cost is so much better than per token cost. And I think this is kind of the big idea of this talk, is that eventually you hit this space where those cost savings, this whole red area, starts to look really, really, really appealing depending on your scale. So there is an additional axis to this that I think is worth calling out, and in that I think a lot of people hear about in the news, and that's really the return on investment. So cost we have is the up-down axis, usage, and then the z-axis is return on investment. So in theory, your return on investment, regardless of these third-party API providers, regardless of the fixed costs for building your own platform, that sort of starts to bottom out. And I think especially in raw training and R&D use cases. So as that usage scales to infinity, your return on investment may flatline. And this is kind of a hot topic among researchers. They're wondering if there really is any kind of ceiling or any kind of technological barrier to where LLMs will take us, where the current iteration of transformers and deep learning, where is that actually going to take us? Is there legitimately a ceiling to these costs? So this is where you start to hear about people kind of building bigger and better and newer data centers with even more network GPUs and even more VRAM, so they can get more and more return on investment for bigger and bigger models. So you might even see where you sort of have these additional forks with additional fixed costs that maybe could give you higher return on investments. I had to put this slide in here because I think it just perfectly illustrates this point. OpenAI and a bunch of their partners are going and building a $500 billion data center called Stargate to, in theory, give them this huge return on investment that could be the GPT 5, 6, 7, et cetera, family of models. And I think, that leads me into a very important caveat to all this is that, none of this is really a perfect three-dimensional economic model. It's probably not even 5 dimensions. It's so many more than that. Like, you have to consider engineering, operations, IT, security, on-premise management, if you're going with a full data center that you're building, power and cooling if you're like leasing the land and actually having to build a building like OpenAI is, the global geopolitics of it all. NVIDIA GPUs are probably going to get dramatically more expensive in the future. So that's kind of everything that you need to consider and what might make sense for you and maybe ends the wax poetic part of this. And I want to get into an actual example of something that we built at OpenSauce, which this last November was recently acquired by the Linux Foundation, and a AI feature in our product that we built called Star Search. So what Star Search was, we kind of thought of it as the co-pilot for your Git history. Not so much about the code, but more about like what was happening in communities. So you could ask questions of it like, what are the most recent releases of Kubernetes? Who contributed to the most recent Kubernetes releases? Or even more sort of esoteric questions like, who are people that know Rust and Tailwind CSS? And it could kind of sift through a bunch of the data we had gathered and worked with our partners at GitHub and Microsoft to go and understand that stuff. So this whole thing essentially was like a ginormous RAG with some early agentic patterns. But this is a snapshot of our very first iteration of this thing. I don't know if it's coming in very clearly, but this was like a few days of turning this thing on. And it was like an immediate thousands and thousands of dollars from the OpenAI bill. We took that initial approach, the bottom left corner of that, where we just wanted to do per token scaling for the cost. And it was that immediate linear scale because at the scale we wanted to build it. For some context, we wanted to build the feature to hit the top 40,000 GitHub repositories across sort of the whole ecosystem, just so we could get a really nice kind of subset and chunk of that ecosystem. And this was a seed stage startup. So we wanted to make a market splash. We wanted to see if we could get some market fit with kind of an impressive AI feature and go from there. So this was going to be kind of ridiculous. Just in a few days, it had already hit $4,100 something. I go back to the product people and I was like, let's do some back of the napkin math. And another caveat with this is these were prices from like a year and a half ago. So we were trying to build this thing like right around when GPT-4 came out, which even now looks kind of unimpressive compared to, 4.1 and 4.0 and all those things. Anyways, so at the time, using GPT-4, it was about $30 per 1 million input tokens and $60 per 1 million output tokens. We were targeting, again, those top 40,000 plus GitHub repositories. We assumed that each of those repositories in these giant data pipelines that we had built were going to be generating about 190 words per day in issues and pull requests. And depending on how you tokenize those words and how kind of the output of all that looks, it would roughly be about $600 per day, which was roughly going to be about $200,000 per year, which, is maybe not a lot for ginormous enterprises, but for an early seed stage startup, this was exorbitant. This was going to be probably cutting into our runway, which is scary for any startup founder or early engineer to hear. So instead, I kind of went back to the drawing table. I said maybe we reduce the scope of this product feature. Maybe we reduce it down to reduce the data pipelines, maybe the top 10,000 GitHub repositories, or maybe we look outside the box and figure out a way to do this without having to reduce scope and still being able to make that market splash. So what we ended up building was a small open weight LLM, or used some small open weight LLMs on some GPUs on top of Kubernetes, which essentially is like the third choice in Mr. Bobby Startup's whole choice of ways he can build some AI infrastructure. We basically brought our own technology, Kubernetes with GPUs, and then built a small GPU-based platform on top of all that. So let's break down some of the technical details of how we did this. This was very scrappy for the time. I'll say that right now. Even at the time, a year and a half ago, technologies on top of Kubernetes like Kubeflow or Q or MLflow or any of these things were not quite ubiquitous with the whole platform, but even now today, there's so many better options. So if you are interested in building a similar type of platform with GPUs on top of Kubernetes, I would urge you to go and look at the CNCF landscape for what's available today. Because that would probably be a better scaling approach. So anyways, what this thing ended up being, and maybe I'll just have a quick aside on what Kubernetes is for those people who don't know. I really like to think of it as just like a bunch of computers that you network together, and then they all together can coordinate and run containers. Containers like on Docker. This is really great for developers because then Docker containers that they develop on their MacBooks can also, in theory, just work on top of a Kubernetes platform. So here's our three computers in this theoretical platform that we built. And what we ended up using was a node pool of a bunch of T4 GPUs. And T4s are NVIDIA GPUs, but they're kind of the most like budgety GPU. Like we weren't going to be spending a bunch of money on, H100 time, which can be upwards of like $2 an hour, which is kind of crazy. T4s were very economical for us, but are still an enterprise grade GPU and kind of hit that sweet spot for us. So each of these nodes inside of this Kubernetes cluster got a T4. So these computers all have T4 GPUs. And then the next step of this whole thing, as we're bootstrapping this platform, is really getting the NVIDIA drivers onto these computers. The GPUs are not going to work without the drivers. Ask any gamer that, and they'll be like, oh, that's obvious, right? But in big scale cloud compute, especially on Kubernetes, this is actually more challenging than you would think. So the way that we approached this problem was actually using a daemon set. Shout out to our partners at Azure, making that relatively easy. But we could actually select for each of these computers on the Kubernetes cluster to then apply some specific labels and things to actually get the piece of software installed on there, long story short. So once we solve for that, all these computers now have the T4. They have the driver for the GPU. Then we could start to actually build on top of that platform. So then what we wanted to use was something that could actually do inference, or in other words, could actually do the sort of chat completion that we needed and generating a bunch of these summaries in this ginormous data pipeline to actually hit the product feature. We used a daemon set with something called VLLM. And what a daemon set is essentially the way to just get a piece of software onto each node. So now at this point, the daemon set, along with the device plugin, has the computer on each node in the Kubernetes cluster. It has the GPU. It has the actual driver for the GPU. And now it has this thing called VLLM. So let's dive into what VLLM is, because I think this is a really important piece of this whole thing. VLLM is an open source technology, sort of like llama.cpp, or maybe people have used OLlama in the past. But essentially, it's an open source piece of technology to make running inference with open weight models relatively simple and easy. One of the ways I sort of like to think about it is like it's like a bucket. You're sort of scaffolding up this model, which really the model is just a bunch of weights with a ton of numbers. And then from those numbers and those network weights, you can actually output some chat stuff. It gives you all these capabilities to use those open large language models that are on Hugging Face, from Mistral, from Meta. Even Microsoft has the Pi models. The Qwen models are super great, are open weight. And from there, you can actually use a concurrent API compatible API, a compatible OpenAI compatible API for utilizing the whole system. So what's really important about this is that we didn't have to change any of the client code, because originally we were using OpenAI's APIs and then could just lift and shift to use this thing. So it looks like OpenAI, it acts like OpenAI. It's not using GPT, it's using some Mistral models, but in theory, those endpoints just give you back the exact same thing. And the client code kind of doesn't care because it's getting its chat completions and it just works. So one of the big reasons we love VLLM, it's an amazing piece of technology. So let's dive a little bit deeper into what an open large language model is, because I think that's really important to understand. So these models, usually you'll find them on Hugging Face, you'll find them on Hugging Face or out on the internet, people talking about them on X or something. And what they are is they're usually freely available. They typically have a permissible license. I'm not a lawyer. Please consult your legal counsel. Some of these licenses are weird. Like the Meta Llama models actually have a very strange license. So please consult your legal counsel, but often it's a permissible license that you can use. They're very small, usually, and very efficient for most use cases. And I would actually argue that a small 7 billion, 14 billion parameter model, like the Mixtral models or the Llama models, can probably get you 98% of the way there, unless you're doing something really crazy with like code gen or like some of the new research stuff that's coming out with like reasoning models. Most open weight models can get you most of the way there, I would argue. And then they're also usually pretty easy to fine tune or requantize for your needs, which gives you all those levers of customization. So this is like, a great choice for people building on top of open technologies who want to bring their own platform or bring their own stuff. And a lot of these models even end up being available in turnkey solutions in the cloud, as like AWS or Gemini or Azure. They just will have these models available to actually use once you accept the license and enable them. Okay, so rewinding a bunch of that, we have all the stuff, all the pieces. We have VLLM. We have our open LLM that we can actually use and scaffold for inference on these things. From this point, we actually want to abstract a bunch of this away inside of the Kubernetes platform that we built. And what this ends up looking like is a Kubernetes service. And that abstraction just ends up looking like OpenAI, and it works really, really well. Again, that OpenAI compatible API makes this almost stupid simple where we didn't have to change a bunch of the client code. And that was really, really nice to enable us to actually accelerate this to market. In Kubernetes, what that ends up looking like is this whole Kubernetes DNS resolved thing. And then that V1 chat completions, which anybody who's built on top of OpenAI will recognize that as an OpenAI compatible endpoint. Okay, so rolling all this back, we have this like platform, this Kubernetes-based platform that we basically built. The next question you have to ask yourself really is like, how do you manage all this? How do you spend engineering time managing it? So we used Pulumi infrastructure as code for managing bootstrapping multiple clusters. We had a beta, alpha, production environments. Made it very simple for our engineers to kind of wrap their heads around getting this all bootstrapped. Love infrastructure as code tooling. We used a bunch of GitHub actions for atomic container builds and deployments, essentially, which became kind of a push deployment methodology. And then we used a bunch of Grafana alerting on call and basic validation to kind of make sure things were A-okay. What challenges did we have? I think this is a very important piece of this. Validation for this whole space, I would argue, is kind of an open question. Like, we have the data. We have these huge data pipelines. We're sending it through this whole like agentic RAG flow in this platform that we built to then answer users' questions based on some unique semantics and things that we've built. But like, how do you validate that whole thing? And how do you validate that like your LLMs that you're deploying on your platform, or even, if it's part of your application, you're using a third-party provider, how are you sure that GPT 4.1 or 4.0 or whatever isn't saying something, kind of wonky to users? This is a challenge. And I think it's still kind of an open question for the broader observability and I guess product observability space. Getting dedicated GPUs on the public cloud is still a challenge. There were a few times that we needed to scale up and needed some more T4s, and the cloud just ran out of capacity, like full stop. Like regions will just run out of GPUs on the public cloud. This is not an uncommon problem either. Especially you'll hear about like H100s getting run out on the public cloud. This alone could be a reason that you would pick the huge investment of going all in on GPUs and actually building a data center or building some racks. Using open models with VLM trained for function calling was a challenge. If you're unsure what function calling is, or tool calling as it's called, this is kind of a newer paradigm around like the agentic flows and the agentic loops that a lot of these applications can get into. Unfortunately, there's, as open source maybe does at times, it's kind of trailing behind what's happening in proprietary. So OpenAI has great function calling capabilities. Anthropic has great function calling capabilities. And only like probably I would say in the last 6 months or so have open models really caught up in a good way in that. So since we were using a bunch of open technology, this was a challenge. We could have narrowed the product scope, like again, full stop. That would have probably been a good idea. But ultimately, we brought this to market. We were able to get some market fit, and this ended up being a good part of the acquisition that happened with the Linux Foundation. So hindsight is always 20/20 with these things. Okay, the decision framework. So we're back to Mr. Bobby Startup. How can we think about this? How can we actually kind of consider what makes sense and what things you should consider as you're going along? I think data governance and sovereignty is like probably one of the most important things, especially that I'm hearing from across the Linux Foundation ecosystem. Some of these platforms are just fine training on your data. Some of these third-party providers. You need to be dramatically aware of the terms of service, especially if you're sending these third-party providers like sensitive information, emails, phone numbers. It is not hard to exfiltrate data out of an LLM, period. So if you need extreme data governance and sovereignty, you need to understand what you're getting into with third-party providers, even with turnkey solutions, and maybe think about going a little further down, depending on your needs. You've exceeded that critical threshold and hit the inflection point. I remember when things kind of go wonky and the inflection point, maybe your costs cannot continue to scale linearly. You need to understand and really ask yourself and your organization, when is that inflection point? When would costs start to be too much? When we actually just need to make an investment and divert some of that money into building our own platform, going hybrid, or even going all in on GPUs. You have special requirements that require a custom solution. Unfortunately, again, we're so early that there are just broad strokes of spaces that do not have solutions yet. Like the chatbot space is basically solved for. But then there's all these other things that LLMs could be used for or could do that maybe you want to like tweak certain things on or do some interesting things with models that you would need some fine tuning on and things. You maybe need to start developing some internal technologies to make that happen, even if it's small, additional pieces on top of a third-party provider, or you're going more hybrid. You need to ask yourself those questions. Engineering and operations talent. This is huge. If you lack some of the expertise to manage and run a data center, you either need to hire or strongly consider not going down that path if you're unwilling to bring on that talent, because that's a whole nother area of expertise that every day Mr. Bobby Startup maybe doesn't have. Okay, commitment, market fit, and go to market. So this gets maybe a little more into like, I'm putting on product hat, and my startup experience. You have to ask yourself how committed you are to this whole like AI bubble, or at least where, especially in the startup space, if you're willing to go all in on these GPUs and spend legitimate capital, that is in itself a commitment to the space. And in itself can be kind of hard to divert away in the future if the market moves away from that. So that's just something to be aware of. But then also, like, if you're trying to hit market fit really quickly, or you're trying to go to market with something like in weeks, not months, not years, then you're probably a little higher up the stack. those third-party providers like OpenAI, Anthropic, again, they're so good for just getting you some AI inference, especially with LLM technology, that you could get to market with something really fast. So it's kind of you got to ask yourself that commitment, where you want to get market fit, how fast you want to get to market.